डॉक्टर बाबासाहेब आंबेडकर ओपन यूनिवर्सिटी.
Hello friends, myself Dr. Alpaba Rajput welcoming you all in the Chaitanya studio of Dr. Babasaheb Ambedkar Open University. Today we are going to discuss about the subject 302 programming principles and algorithm. In earlier session we have discussed the various control structure statements, various looping statements which will be used to execute the specific piece of code. We have seen the various functions related to solve the specific problem, in which we have included, we are using the function which will execute the block of code to find the specific output. On basis of their return type and the argument that we are passing into the function, there is various types of functions. In that also we have discussed the problem solving, the definition of a problem solving, and a various techniques of the problem solving like error and trial, divide and conquer, and brainstorming. In today's session we are continuing with a problem solving, and we are going to focus on an algorithm, flowchart, and a pseudocode that we are using to precisely define the problem for getting the specific solution. So, let me first of all start with the algorithm definition. An algorithm is a series of a finite number of steps which is shown in a particular order. It defines the specific order from startup to the ending for getting the specific solution, so as to generate the solution for required problem. For a startup to the end, where we are converting the problem to the specific solution, all the steps for that procedure will be included step by steps into the algorithm. It serves as a systematic approach, systematic procedure that computers required to solve any problem. Algorithm is defined computational process that carries a set of instruction which contains some values or maybe a set of value, and the purpose of getting this value is what? To generate a set of value as an output. So, here in algorithm we are getting the set of input for generating the set of output. The algorithm accepts the data, it will manipulate the data, and by manipulating that data it gives the desired value as an output. Whatever the value we actually required as an output, that we will get at the end. So, basically algorithm, we are passing some input and finally we are getting some output. Basic characteristic of an algorithm is algorithm should be exact. Algorithm should be defined or drawn in such a way should be exact meet the requirement of a problem or a solution. Okay. Algorithm should be terminate. We should put certain condition to the algorithm, so the condition should be should get the problem in program to certain end, otherwise it will go for the infinite loop and the program will never be terminated. Okay. So, algorithm should have some termination value. Algorithm should be effective in a manner that it got to the specific solution. It should be effective to finding the specific solution that of a problem that we actually required. An algorithm should be general, it should be in a general manner. For that kind of all the problems we can apply the same algorithm. The basic need for the algorithms are the input, generate as an output, unambiguous, generality, correctness, finiteness, and efficiency. The basic advantage of algorithm is provide the efficiency for solving the specific problem. It should have it's provide the abstraction. It divides the bigger problem into the smaller problems. So we can better way we can find the solution, and it having the concept of reusability. Same algorithm we can use for the multiple way we can use for the multiple problems. Okay. The flow chart. A flow chart is a graphical representation of an algorithm or its process. Simply we are converting our algorithm, which defines the step by step process of a problem solving. We are providing the graphical representation of that algorithm by the flow chart. Every steps in the process is shown by a symbol. Here in place of a textual version, we are using a graphical version of a programming that gives the short description of the problem. On basis of that flow, that specific symbol, we can identify what process is going on. The symbols in the flow chart are connected together with the arrows. Here we are using arrows to connect the multiple symbols. We show the flow of a process, and by that arrow we are defining the actual flow of the process, in which specific direction it goes. A flow chart shows the process of operations that works in sequence in order to solve a particular problem. Okay. And to understand the process, the flow chart gives you the way out step by step graphical representation. In place of textual representation, always the graphical representation is quite better, right? A flow chart defines how a process should work. A flow chart basically serves as a communication tool among the programmer and a people, because as I told you, graphical representation is a better way to communicate, useful in understanding the complicated logic. It converts the complicated logic into the simpler logic. Once the flow chart is drawn, it becomes easy for programmer to design a program in any high level language. After the flow chart is drawn from the algorithm, now it becomes quite easy for the programmer to convert it to a code by using any high level languages. Okay. So, the basic advantages of a flow chart are good way of communicating the logic of a system by the graphical notation, helpful in analyzing the problem in an effective way, serve as a effective program documentation. For the documentation purpose, graphical notations are used, kind of blueprint of a program which is helpful in development phase. We can use that flow chart for the development purpose. Effective tool for debugging a process. On basis of the flow chart, even our debugging process becomes quite easy. It helps the programmer to show effort efficiently on a particular part of a program. From the flow of program, we can identify which specific part required the efforts to solve. These are the various symbols that are used in a representation of a flow chart. Here we are using the terminal which having the oval shape, which is basically used to define the beginning and the end of a specific action. So, at the startup level, whenever we are starting the flow, the first step is to define the terminal, which defines the starting and ending of a flow. From this symbol, we can identify that this is the startup, and when finally this symbol comes, we can get an idea. Here we are in between, we are defining the text through which we can give the message also. Okay. This is a symbol for defining the input and output. It is having the parallelogram shape, which is basically used to define the input and output. The input that we are getting from the user, as well as any output that we are going to print on a console. Okay. So, for that we are using the parallelogram shape to define the input and output. Then, if you are doing any processing on a specific input, if you wanted to define that process, then this specific symbol of a rectangle shape will be used here on a required and whatever the input we are getting, whatever the process we are doing that input on that input, that will be defined in this symbol. Okay. Then we are having the connector which are a circular in a shape. Any entry connector we wanted to use, then the arrow will be passed from that activity. If any connector ki jyan any flow is coming into it, then this way the arrow will be shown, and basically this arrow is defining the flow of a code. Okay. It will be define the flow of a code. If we wanted to define any kind of condition, then we are having this diamond shape. Okay. We are defining the diamond shape. Here we are defining the yes or no condition if the specific condition is true or if the specific condition getting false. Okay. If you are looping condition, then again and again the loop will be gone into the shape. Okay. So, basically the diamond shape is used to define the just include the condition. Okay. So, let us see it with a simple example. This is a flow chart for the very simple program where we are reading 3 integer from the console and we are printing some value on a console. Okay. So, here as we can see, we have the startup shape which is known as a terminal shape. Terminal shape is defining what? A starting and a ending of a flow. So, here by this terminal shape we are defining the starting and the ending of a flow, right. Then here we have parallelogram shape we have that is basically used to getting some input or output. Okay. So, here we are reading x, y, z value from the console. So, it is use a parallelogram shape. Okay. Then here we are doing some processing on that specific input. So, it will be defined in this kind of rectangular shape, and finally we want to print something on a console. So, we are using the parallelogram shape to print the output. Okay. The second is a pseudocode. Pseudocode is nothing but a form of algorithm in a way of either in an English statement as a mathematical notation or as an keywords. In a flowchart, what we are doing, we are converting the algorithm into a graphical symbols. We are representing the same thing of algorithm in a graphical manner. In a pseudocode, we are representing the algorithm, but in a English statement or using the some mathematical notation or with a keyword in a textual version only, and it can be represented with different styles and is explained with a certain clarity. So, it is a human readable form of an algorithm. Okay. Algorithm is a systematic way to define your process, whereas the pseudocode is a human readable language to represent the algorithm. Pseudocode is an informal, is not a formal, high level description of the operating principles of a computer program or the other algorithm. It uses a structural conventions of a normal programming language, but is intended for human reading rather than machine reading. It is not a machine reading purpose, it just to make the people understand what the process is going on. Okay. Simplest form of pseudocode. Here we are reading some values from the terminal. So, we are simply writing some command read. We are always whatever the commands we are using, that we are putting basically in a capital letter in a pseudocode. Okay. So, we can get that is the kind of instruction, right. So, these are the variables we are reading, we are processing on that variables, and finally, we are writing that values on a terminal again, right. The basic rules, though there are no rule for the pseudocode, but certain rules we are using for just differentiating the text, right. So we are only one statement per line, we are using only single statement per line. Multiple statement we are not including in a pseudocode in a single line. Capitalization initial keyword. For our reference purpose, we are basically whatever the initial keywords are there, that will be capitalized. Like we want to read something, we want to write something, we are using any loop, that will always be in a capital letter. Indent to show the hierarchy and structure. We always in a pseudocode, indentation are done to defining the hierarchy and a structure and the multi-line structure. We always ending the multi-line structure and keep the statement language independent. It is not binded with any language, it is just a human readable textual version of an algorithm. Okay. We can use the various operators into the pseudocode, like plus, minus, multiplication, division. We can use the equal sign also. We can use some mathematical operators to assigning some value. We can use the arrows, like a and a b summation will be assigned to sum. Like this kind of mathematical notation we can use into the pseudocode. If you want to define the iterative, if you want to define some iteration in the pseudocode, that means the loops. So it can be states for an repetition of code, that we can define into the pseudocode also. Okay. So iteration can also be defined in a pseudocode. There are various kind of logical structure we can define by the pseudocode. Are sequential structure, where we are having the step by step process. A selection structure, like if, then, else, or if and this then. Iteration structure, like while, and while, or repeat, until. Okay. So we may have include this kind of structures, control structure also we can implement by the pseudocode. Okay. Let me see the simple sequence structure flow and the pseudocode for that specific code. Okay. Suppose we are having the flow chart where the process 1 is done, process 2 is done. In the sequential manner, the process 1, 2, 3 like that is running. So in that case is what will be the pseudocode for that? Number of statements here we have defined by the dot, and the process 1 and process 2 is following. So, okay. So one after another in a particular series we are defining the process execution. Okay. And the flow of this one will be top to the bottom, the first process, second process, third process. In this way we are defining the process. If we are having the selection structure, like if, then, else, or if, then, if the specific condition arise, then the specific statements. So in this in this case we are having, suppose flowchart, we are checking some condition. If the condition is true, then we are following the specific processor. If the condition is false, we are following the specific process. So if for the, what will be the pseudocode for that? If the specific condition, then process 1, else process 2. Here whatever the statement initial keywords we are using, that will always be in a capital. Okay. Else, else, else. In this way multiple else conditions we are providing. So if, then, else, then, like this way we can provide the pseudocode. If we are having the if and a then, simple condition, yes or no kind of. So that for that the pseudocode will be if the specific condition, then the process 1, and if. Here we have defined the indent to define the hierarchy of the process to be executed. If we are using the iteration, like while and while iteration we are using. Okay. See here we are having some counting value, we are checking if till the count is less than 10, add 1 to count and writing the count, and again the process should be run till the count not reach at the 10, right. So main module version is what? While the count is less than 10, what we have need to process it and have need to add 1 to count. The pseudocode for it is count equal to 0, while count is less than 8, add 1 to count, write count, end while, and finally write the end. Okay. Then we are having the repeat and until, that will be defined by the pseudo like this: repeat, add 1 to count, write count until the count is equal to 10. Same logic, but in place of while and end while we are using the repeat and until. So, in this way we can define the pseudo code for defining the iteration, right. Let me see all the algorithm, pseudo code and a flow chart, how we can draw for a specific problem with a simple example. Okay. Like we are having the simple example where we wanted to do the result. We want to generate the result of a students, whether the students is pass or fail. Okay. We are having the marks of 4 subject of a students, and we want to identify whether the student is pass or a fail. Okay. The basic criteria is, if the average of 4 subject is less than 50, then the person is fail, otherwise he is pass. Okay. So, here what will be the pseudo code for that is input a group of 4 marks. As I told you, pseudo code is just a human reading form. So, it is not related with the programming at all. Okay. So, here simply as a textual version we are defining, like we have need to input a group of 4 marks, 4 subject marks, calculate their average by summing and dividing by a 4. So, we can identify by whatever the marks we have got, that we have need to find the average of it, right. And if the average is below 50, we have need to print the fail, else print pass. So, simply in a textual version which can be identified the human, in that manner the pseudo code is defined. Now, let me see the systematic version of this is an algorithm. So, here in first step is what? We are inputting the 4 values M1, M2, M3 and 4, which represent the subject value. Step 2, we need to identify the summation of that number, and we have need to get the average of it. So, what we will do? We will do the summation of that all the marks, and we will divide it with the 4 to get the average of it, and whatever the value we are getting, that will be stored in a grade. Now, we are checking whether if the grade is less than 50, then print the fail, else print the pass. So, this is a systematic machine readable form of program. And let me see the graphical version of this. Starting, we are inputting the 4 subject value. If the grade is less than the average value, is grade is less than 50, yes, the print fail, if no, the print pass and stop. Okay. So, we are using the terminator, we are using the input output parallelogram shape, we are using the process, and we are defining the diamond shape to draw the condition, and on basis of this we can provide the systematic graphical representation of a problem. Okay. So, this is the flow chart. Thank you very much.